You sit down at a keyboard, type out a prompt, and almost instantly, a chatbot begins spitting out paragraph after paragraph of fluent, coherent text. It tracks the characters, follows the plot, and adjusts its tone on command. Behind the screen, the bot follows a specific objective. It identifies which single word is statistically most likely to appear next in the sequence. Tools like ChatGPT belong to a category known as Generative Pretrained Transformers. That last word, transformer, refers to a particular type of neural network architecture. Introduced in 2017 by Google, the transformer was originally built to translate text from one language to another. Today's models take a piece of input text and process it to produce a probability distribution. They assign a percentage to thousands of possible words, ranking which chunk of text is most likely to follow the sequence. To understand how these probabilities create convincing language, we have to follow the data as it flows through the mathematical pipeline. The pipeline begins by breaking your input text down into smaller pieces called tokens. These can be full words, pieces of words, or even single characters. Computers translate tokens into lists of numbers, assigning each word a specific coordinate in a massive high-dimensional space. During training, the model organizes this geometry so specific directions correlate with meaning. Starting at king, subtracting man, and adding woman lands exactly on queen. The machine organizes complex historical context using these same geometric rules. Take the coordinates for Italy, subtract Germany, add Hitler, and the resulting math drops you onto the vector for Benito Mussolini. The model uses a calculation called a dot product to measure how well two vectors align. This lets the system quantify abstract concepts, like how plural a word is, by seeing how much its vector points in a specific plurality direction. The computer navigates a vast spatial map where human meaning is encoded entirely in its distance and direction. At the very start of the pipeline, each vector represents a single token in total isolation. To give those isolated words situational meaning, the original vectors are fed through a gauntlet of matrix multiplication. This engine contains billions of tunable parameters, the numerical weights the model learned during its training. As data flows through operations known as attention blocks, the vectors pass information back and forth. They talk to their neighbors, updating their individual values based on the surrounding text. Think about the word model. If the surrounding vectors belong to the phrase machine learning, the math shifts the coordinates of model in one direction. If the surrounding text is fashion, the values are pulled somewhere else entirely. All 175 billion parameters within a network like GPT-3 exist entirely to stretch and physically pull these vectors until the final point in the sequence encodes the specific, nuanced context of the entire passage. Imagine the final vector arriving at the end of the pipeline. It has absorbed the context of the user's prompt, perhaps an essay about Harry Potter's least favorite teacher, and now it must pick the next word. The model compares that final, context-rich vector against every single word in its vocabulary. It outputs what are called logits, raw numbers, some massive and some negative, assigned to all 50,000 possible tokens. This chart shows the raw values passing through a function called softmax. Softmax compresses the chaotic inputs into a strict probability distribution between 0 and 1 that adds up perfectly to 100%. A user control known as temperature can adjust this function. If you set the temperature to 0, the math forces nearly all the weight onto the highest ranked value. The AI will select the most probable word every single time, resulting in repetitive, predictable text. By increasing the temperature, you boost the lower ranked values. The AI gains the flexibility to select less likely words, introducing a mathematically controlled sense of risk into the writing. Once the model takes a sample from this distribution, it spits out the winning word and immediately appends it to the end of your original prompt. Then it runs the entire 175 billion parameter calculation from scratch. Every matrix multiplication, every context update, and every softmax compression happens again, just to guess the next single word. This fast, relentless loop of geometry, probability, and matrix multiplication operates at a scale that effectively mimics the nuances of the human mind.